Welcome to today's Explainer. We're diving right in, and I am super excited you're here because we are literally going behind the curtain of the recycling industry today. We hear so much about collection rates and the circular economy, but very few people actually focus on the physical machinery doing the heavy lifting. So today, we're going to explore how structured maintenance management is the hidden engine that actually makes sustainability possible. Okay, let's shatter a massive illusion right off the bat. When most of us think of recycling, we picture, clean office bins and tidy little sorting stations. But the reality? Oh man, mechanically speaking, a materials recovery facility is way closer to a brutal, heavy-duty mining or cement operation. It's tough, it's abrasive, and it is incredibly unforgiving. To see how this heavy industrial maintenance is the literal engine of sustainability, here's what we're covering today. First, the recycling myth, then the cost of chaos, layered maintenance strategies, the 4 levers of sustainability, and finally, the true cost of reliability. All right, let's jump straight into section 1, the recycling myth and the brutal reality of material recovery. Here's the wild part. The equipment, your shredders, balers, sorters, they're operating in incredibly abrasive, moisture-heavy conditions. But the real kicker? The feedstock composition changes literally every single day. You never know exactly what's coming down that conveyor belt. Because of that, components like bearings, blades, and screens degrade on a steep, entirely unpredictable curve compared to cleaner industries. Moving on to section 2, the cost of chaos, where we look at the financial toll of unplanned downtime. Now, I want you to really think about this for a second. What is the actual, real-world cost when a critical shredder or baler just dies? What's the operational and financial fallout when the literal heartbeat of your facility suddenly stops beating? Well, check out this number right here, 144. That is the average number of unplanned downtime events a recycling facility deals with every single year. I mean, do the math. That's a major mechanical failure roughly every 2.5 days. It's not just a minor hiccup, it's practically a constant state of emergency. And here's the consequence of those 144 events, an estimated $2.3 million in annual costs. Yeah, $2.3 million. That comes from lost processing throughput, crazy expensive emergency labor, and the huge premium you end up paying to overnight parts just to get the belts moving again. The machines demand that you spend about 5 to 10% of their replacement value on maintenance every year. That's just not optional. But this quote really hits the nail on the head. The only question a maintenance manager actually controls is whether that spending happens on a predictable schedule or in a chaotic, wildly expensive ambulance. So how do we fix it? That brings us to section 3, layered maintenance strategies matching the exact tactic to the asset. Because a single strategy just won't cut it across a whole plant, you have to build a layered approach. You use preventive maintenance for your wear parts, like swapping shredder blades on a fixed schedule. Then, condition-based monitoring handles hydraulics, keeping an eye on the heavy, cyclic loads on balers. And you reserve predictive maintenance, like vibration or thermal analysis, for assets where a failure is just too costly or dangerous. It's all about perfectly matching the tactic to how that specific machine fails. Now, you might be wondering, and it's a super common question, can you actually use predictive maintenance on older recycling equipment? Do you need a brand new, high-tech machine for these fancy sensors to work? The answer is absolutely yes. You definitely don't need shiny new machines. Retrofitting vibration sensors or thermal cameras onto legacy shredders is actually incredibly cost-effective. Why? Because we already know exactly how these older machines fail. Their failure modes are totally understood, which makes this a super accessible and massive upgrade for basically any facility. Okay, let's shift gears to section 4, the 4 levers of sustainability and how maintenance directly drives environmental output. So, a robust, computerized maintenance management system, or CMMS, needs to focus on these 4 main levers to hit sustainability goals: sorting accuracy, energy consumption, spare parts availability, and safety-critical systems. Let's look at how ignoring these can completely derail a facility's green mission. Take sorting accuracy, for example. If you skip a scheduled lens cleaning on an optical sorter, it doesn't beep or flash a warning. Instead, you get what's called optical sorter drift. The lenses just get dusty and the machine quietly starts sending perfectly good recyclables straight into the residual waste stream, the landfill. There's literally no alarm. You won't even know it's happening until a buyer outright rejects your contaminated load. Just like that, your diversion rates tank, all because of a missed wipe down. Then there's the energy side of things. It usually happens like this. First, a bearing starts to wear out or a belt slips. Because of that friction, the machine has to fight much harder, so the electrical load required to process the material jumps up. Suddenly, your energy consumption per ton spikes. But here's the cool part. If you track that energy data alongside your maintenance logs, your basic energy dashboard suddenly transforms into an early warning system. You can spot mechanical degradation weeks before a part actually snaps. And we absolutely can't forget about spare parts. I mean, knowing the exact wear cycle of a shredder blade is completely useless if the replacement part isn't sitting on the shelf when you need it. If you under-budget your lead times, what should be a simple, predictable 2-hour repair turns into a grueling multi-day facility stoppage just because you're waiting on shipping. Which brings us to our final stop, Section 5, the true cost of reliability and why maintenance literally is sustainability. So what does this all mean for the big picture? How does a maintenance management system actually help with corporate sustainability reporting? Basically, how do we connect the mechanic working on the shop floor to the investor sitting in the boardroom? Well, it comes down to data. Dedicated platforms like ManWinWin, for instance, provide the auditable data you absolutely need for robust ESG reporting. We're talking about a hard, verified record of equipment uptime, a logged history of sensor calibrations, and highly accurate energy consumption numbers. Without this stuff, your sustainability claims are just hopeful guesses. But with a CMMS, your environmental reports are backed by hard, logged facts. And that brings us to an incredibly powerful realization. A plant manager who treats maintenance as just a cost center will inevitably see it show up as a sustainability failure. Missed diversion targets, rejected loads, extra emissions from struggling machines. Those aren't just bad luck. They are the direct symptoms of poorly tuned equipment. Maintenance discipline and sustainability performance aren't separate things. They're the exact same problem, viewed from two different angles. So, I'm going to leave you with this final thought to chew on. If you aren't rigorously managing the mechanical reliability of your recycling plant, are you actually running a green facility? Or are you just waiting for the next ambulance? Think about it. Challenge your operational strategy. Dig into those maintenance logs and make sure your green targets are actually built on a rock-solid foundation of reliability. Thanks so much for hanging out with me for this explainer, and keep on learning.